Hello students, we have learned that colligative properties are dependent only on the number of solute particles and not on its nature. Now we'll see what happens when a non-volatile solute is added to a solvent. We have learned that when a non-volatile solute is added to a solvent, there is a considerable decrease in the vapor pressure, which affects the boiling point as well as the freezing point. You find that the boiling point is increased to a greater extent, whereas the freezing point gets decreased. All these come under colligative properties. What happens actually when salt is put in water? We know salt is sodium chloride. It is an example for an ionic compound. When it is put in water, it will ionize and form sodium ions and chloride ions. If we have taken 1 mole of sodium chloride initially, we find that after it dissolves, it forms 1 mole of sodium ions and 1 mole of chloride ions. So, checking the number of particles here, you find that 1 mole of the substance will produce 2 moles of the ions. With the result, the number of particles increases. When the number of solute particles increases, there will be an increase in the colligative property. Now you check the molecular mass of the substance. Here, sodium is having the atomic weight 23, whereas chlorine has 35.5. With the result, the total molar mass will be 58.5. So, when it is put in water, you find that the dilute solution of sodium chloride, if the molar mass is found out, you find that it is only half the value of 58.5. That is, it comes to around 29.25. What happens here? That we are going to discuss. At the same time, if instead of sodium chloride, if you have taken an organic compound like acetic acid, acetic acid is ethanoic acid with the formula CH3COOH. When it is taken in benzene, you find that acetic acid becomes the solute and benzene is the solvent. So when an organic compound is dissolved in an organic solvent or a non-polar solvent which is having very low dielectric constant, you find that it undergoes dimerization. This happens because there is the formation of intermolecular hydrogen bonding. So what happens here? Acetic acid, which can be written as CH3C double bond O single bond OH. The next CH3COH molecules comes nearby in another pattern, and there arises a bonding here due to intermolecular hydrogen bonding. With the result, what happens is, if we have taken 2 moles of the substance, it forms a single unit of a dimer. So with the result, the number of particles here decreases. What is the molar mass of acetic acid? The molecular mass of C2H4O2 is found to be 60 U. Therefore, the molar mass becomes 60 grams, and that of the dimer, it has the molecular mass of 120 U and its molar mass becomes 120 grams. Here, the dimer has the double the molecular mass compared to that of acetic acid. This occurs due to association. So, in order to explain the cases of dissociation and association, the scientist named Van Hoff introduced a correction factor in all the colligative property equations. So accordingly, Van Hoff gave the equation, that is Van Hoff correction factor, written by I. It is nothing but the colligative property observed colligative property divided by the actual colligative property. The colligative properties are dependent on the total number of particles that are present. So it can also be related to the equation I is equal to total number of particles after association or dissociation divided by total number of particles before association or dissociation. This also can be related to the molar masses. You find I is also related to actual molar mass divided by abnormal molar mass. You have seen earlier when sodium chloride solution was estimated, the molar mass of the solution was found to be half of the original calculated value. Same way, when we are checking the solution of acetic acid in benzene, we find that the molar mass is double the value of the calculated value. Why this happens? This occurs because of the phenomena called dissociation or association. So what actually happens during dissociation or association? That we will be learning in this part. You have learned earlier that colligative properties are proportional to number of solute particles. In the case of dissociation, take the example of sodium chloride. You find sodium chloride will dissociate to form Na plus ions and Cl minus ions. So if initially we had 1 mole, you find that at the initial stage only sodium chloride is present. So sodium ions and chloride ions will be 0 at the beginning. After a time t at a concentration, you find that if alpha particles are undergoing dissociation, if alpha particles dissociate, you find that the final volume of the solution becomes 1 minus alpha, that remains undissociated, and if alpha particles have undergone dissociation, it has converted to alpha particles of sodium ions and alpha particles of chloride ions. With the result, you find that the I value can be calculated using the formula total number of particles after dissociation divided by total number of particles before dissociation. So what is the number of particles after dissociation? Here you find that it is 1 minus alpha plus alpha sodium ions plus alpha chloride ions, and initially we had 1 mole of the substance. So then what will be the I value? I value will be equal to 1 plus alpha, where alpha is the degree of dissociation. This is how you find the Van Hoff factor in the case of dissociation. In the case of dissociation, we can generalize that I value is always greater than 1. Now we shall consider what happens during association in associated molecules. We take the example of acetic acid in benzene. Acetic acid has the formula CH3COOH. Two molecules of acetic acid in the presence of benzene solvent undergoes association, or it dimerizes to form CH3C double bond O single bond OH. Second one CH3C double bond O single bond OH. So it undergoes association to form the dimer of acetic acid. So initially, if suppose we have taken the initial concentration, if it is taken as 1 mole of the substance, we find that the product has not been formed, so the value is 0 for the dimer, and after a time t at equilibrium concentration, we find if alpha particles associate together, if alpha particles associate, you find that at equilibrium concentration, the concentration of acetic acid becomes 1 minus alpha. So alpha particles have undergone association, so one particle will change to half. Two particles are changing to one. That means one particle will be changing to half. So alpha particles, if present, it will be converted to alpha by 2. With the result, the I value can be calculated using the formula number of solute particles after association divided by number of solute particles before association. So it will be 1 minus alpha plus alpha by 2 divided by initial it is 1. So what will be the value? It becomes 1 minus alpha by 2. With the result, we can generalize in the case of associated molecules, the I value will be always less than 1. If neither association nor dissociation occurs, you find that Van Hoff factor will be equal to 1. Thank you.